Hello, everyone. Welcome to the Mechatronics class. I am your teacher, Mo Chen Jia. The conveyor is a crucial component of an industrial automation production line. Based on the production rhythm of the line, materials are transported from one side of the conveyor to the other at regular intervals to achieve material transportation. Next, we will cover the following topics. Learning objectives. 1. Learn the methods for creating collision bodies, object sources, object sinks, collision sensors, and transport surfaces. 2. Master the basic components and working principles of the conveyor system. Now let's look at the specific operation steps. We will start with a demonstration of the specific operation steps. Open the case model, select the application, find the panel of design, choose More, and from the drop-down menu, select Mechatronic Concept Design to enter the MCD module. Select the Physics Navigator from the left resource bar to enter the Physics Navigator panel. Before starting the motion simulation, we first familiarize ourselves with the general term and working principle of the conveyor. The conveyor consists of components including transported material, sensors to check the arrival of materials, suction cups, Z-axis, X-axis, and material sinks. The working process can be described as follows. Under the action of the conveyor, the material moves forward. When it contacts the collision sensor, a signal is triggered, causing the conveyor to stop moving. The suction cup absorbs the material and places it into the material sink, thus completing a movement cycle. During this motion process, we can observe that there are three objects involved in the movement: the material, the Z-axis, and the X-axis. Next, we create the three moving objects as rigid bodies. Select rigid body, then choose the X-axis and create it as a rigid body. Click Apply to complete the creation of rigid body of the X-axis. Select the Z-axis and the suction cup. Create them as a single rigid body and name it Z-axis. Click Apply to complete the creation of rigid body of the Z-axis. Finally, we will create the material as a rigid body. Click OK to finish creating the three cylinders. Before the material moves forward and collides with the collision sensor, if we want the sensor to detect the material, we need to set the material as a collision body. Select Collision Body, set the material as a collision body. Then click OK to complete the creation of collision body of the material. We can click play to see the object we created as rigid body. Since they are not constrained, they will experience free fall. Therefore, we need to create the floor as a collision body to support the mass of this object. Select Ground, create it as a collision body, name it Transport Surface. Then click OK to complete the creation of collision body of the transport surface. During the motion, this material will continuously be generated, so we will create it as an object source. Select Material and click OK to create it as an object source. We will set the object sink as an object sink. Which must be a collision sensor. So, we first need to set the sink as a collision sensor. Select Collision Sensor. Choose the collision shape as mesh. Click on the sink, name it Material Sink. and click OK to complete the creation of the material sink. We will return and set it as an object sink. Select the collision sensor we just created and set it as an object sink. Thus, we have completed the creation of the basic physics. Next, we will create the basic joint. In the motion of this object, there is only one type of motion, namely the left and right, and up and down sliding of the x-axis and z-axis. Select basic joint and choose the x-axis as the attachment, with its vector directed to the left, creating it as a sliding joint. Next, we will create the z-axis as a fixed joint. Select fixed joint and choose the z-axis as the base. This choice allows us to select the material as the attachment in subsequent operations, thus achieving the effect of a suction cup grabbing the material. Click OK to complete the creation of the fixed joint. Next, we will create the z-axis as a sliding joint. For this sliding joint, we need to select the z-axis as the attachment and the x-axis as the base, choosing the vector to be upward. Click OK to complete the creation of the joint. Now, let's create the sensors and actuators. In this motion system, we have set the material sink as a collision sensor. If we want to detect the arrival of the material as it moves forward, we need to set this cylinder as a collision sensor. Select the collision sensor, choose the collision shape as mesh, and select the outer surface of the cylinder to create it as a collision sensor. Click OK to complete the creation of the collision sensor.